Hello testers, and welcome to another SDP community webinar. I know this is not a voice you're used to hearing on this webinar, but my name is Mike Lyles. I'm the Director of Strategy with STP and a longtime friend and supporter, and I'm an IT director in my current company as well. And we're excited to have everyone on the webinar today. Laveena Ramchandani is joining us from London, and she will be talking about how to better understand what data science is and how you can better structure your team in order to have a confidence in the data produced. So stick around. We got a few things to go over before we start the day. Coming this summer, I'm so excited to be part of this program as well. The Mile High Software Testing Conference is going to be in Denver at the end of this month, July the 27th through the 28th. This in-person event is going to take place over 2 days. It's going to include a mix of 3-hour in-depth workshops, 90-minute sessions, and 45-minute breakout talks. And this event will consist of all testing topics around agile, automation, mobile, accessibility, artificial intelligence, strategy, and everything in between. So if you're ready to take your testing experience to the next level, join us on July 27th and 28th. For this conference in Denver. And you can visit milehighTesting.com to learn more and register for this in-person conference. I know a lot of you are probably saying, I need to get back in person. This is your chance. We've been waiting for this. Thank you to COVID. If you're on social media and you're talking about today's webinar, make sure you tag us at SoftwareTestPro and use the tag STP webinar. And also be sure to give Laveena a follow-up while you're at it. Her ID is at Laveena_18. So with that, please welcome Laveena. We're excited to have you today with us, Laveena, and part of our community webinar series. And we're going to give you control, and the floor is all yours.
Thank you very much. Hello, everyone. Welcome to the conference today. As Mike has already introduced me, I'm Laveena, I'm from London, and I'm more than happy to share loads of data science and testing knowledge with you today. Thank you, STPCon, for giving me this opportunity, and I'm going to get started then. So, testing a data science model. So, a little bit about myself. So, I'm a graduate with a BSc Honours in Computer Science. I've fallen into testing. It was a good fall for sure, because I quite enjoy it. I've been testing for over 8 years now. I've worked in various industries, as you can see, some of them being oil and gas, transport, financial services, consumer goods. And some of my hobbies include dancing, yoga, teaching, and baking. Today's table of contents. What is a data science model? So I'll give you some background knowledge around what is a data science model and give you the main basics that you need to understand. Then the process around how should we test these, and then some useful tips for you to take away and potentially introduce them into your teams. Currently, 80% of UK businesses are looking to hire a data scientist or seek data consultancy. This is just the UK statistics, but I'm sure all around the world, data scientists are quite a lot in demand. IBM anticipates that data science will account for 28% of all digital jobs by 2020. So these statistics are really, really interesting. Now, what made me really intrigued about this stat is if there is a ask for data scientists, what about ask for testers to test the work of a data scientist? So that's why my aim in this talk is to actually motivate you to actually get involved in data science projects in your companies and see how you can actually gain more confidence from the models that data scientists build. Also wanted to give you some kind of extra information that you can search and some case studies that you can look into. First one being Uber. You can check that how they use data science. Netflix and Amazon Prime use data science, and loads of banks use it as well for credit card fraud, for example. What is data science? It's a collection of tools and algorithms to unveil hidden patterns from raw data. It allows decisions and predictions to be made with the aim of making informed decisions. So it's basically to make sure something, basically, it's a forward-looking approach and more of a real-world scenario situation. And it's an exploratory way with the focus on analyzing the past or the current data. Your first buzzword of the session is predictive analytics. So why do organizations, or especially data scientists, use predictive analytics? Because organizations can find and look into patterns contained within data in order to detect risks and opportunities. I'm just quickly going to stop here. Mike, just a quick one. Can you hear me still? Yeah? Everything okay?
Yes, you're coming in good.
Perfect. Yeah, perfect. Because in the past it's gone off in the middle of it. So I thought I'm going to ask everything's okay. Perfect. So I've got the thumbs up. Right. So this was data science for you then. Off we go to understand what a model is then. So I thought to help you understand the model better, I'm going to give you a very interesting analogy. So imagine you're driving into work in the morning. You get into your car, you put your seatbelt on, you put some radio on, get some nice music flowing through, have your air conditioning on because it's quite warm these days, and you start your little journey. So what is that? That is the data side of things, your driving experience. And then what you do next is you get into the main roads and you're potentially trying your best to get into work as soon as possible. So trying not to get stuck into traffic. So if you do get into traffic, what will you do? Your brain will try different driving patterns to learn what works best. So that's your computing side of things. So if, say, for instance, you have got into traffic, then you're going to find ways to get out of it as well. So maybe you might do a U-turn, or maybe you might find another easier shortcut that is for you to get to work sooner rather than later. And the model side of things is basically an equation of data inputs affecting a target value. In this case, the target value is how long it takes for you to get to work. So if you're going to use patterns that are going to make you stay longer on the roads, then you need your model to be more optimized. However, if you are optimizing your model often, then your model is actually much more optimized and better to use. So you might not need to keep optimizing it. Another example I can give you is, say for instance, for a manufacturing firm, you can check what they sold last week and check if the same assumptions were used, then what is an acceptable sale for next week? This is basically a sales data of a client to improve their production. A model basically assesses a set of conditions and guides you to make informed decisions. Remember, a model is a statistical black box. Models use probability distribution to understand the behavior of its inputs. It's more of a what if kind of model. So if a customer uses parameters for a model that we suggest, for example, then what their business could look like. Your buzzword number 2, which I will explain a bit later on, is genetic algorithms. So models tend to use genetic algorithms as well. It's basically an algorithm that reflects the process of natural selection, where the fittest individuals are selected. And it's inspired by Charles Darwin. Next, the model produces some indications as well that are being used as a guideline by our clients. And what do we do as testers in this case? We are basically testing against an expected outcome. Some benefits of a data science model. It helps craft better decision making, identifying opportunities for companies that they didn't think about before. Actions are based on trends to help define goals. It's a data-driven evidence, so loads of data is involved. Identification and refining of target results, and mimics real-life scenarios. Now, we know that data science models include a lot of data. So let's learn a little bit around the data. So as you can see, we sometimes have structured data, we have semi-structured data, we have unstructured or metadata. So structured data adheres to predefined data models. It's easy to aggregate data from various locations and databases, easy to store, access, and process, such as Excel files. Then you have unstructured data, which is not organized in a predefined manner. It has irregularities in the data, therefore quite ambiguous. Example, videos or audio. Then you have semi-structured data, which is basically self-describing data, such as tags or markers. for example, on JSON or XML files. And lastly, metadata, which provides additional information about a dataset. For instance, a photograph, where was it taken and when was it taken? So these are the kind of data that you could potentially use for your model. In my case, I used a mix of semi-structured and unstructured data initially. Initially, we had unstructured data because we just asked the companies to send us whatever they have, and then the data engineers would actually work on it and send the data for me to test on. Now, this can actually lead to data biases. So to avoid that, what we did was we created JSON files and we sent those to our clients. And then we told them this is the format we want our data in so that the model can accept it and we don't need to change nothing. Let me give you a little small example here around a little architecture that I've created. So what's happening here is you have, for example, your database, your logs. So you have your raw data come in, which is your data extraction. Then you have your features, so basically all the new features that you are building in the team and testing, so that's your feature extraction and pre-processing. And then you have your learning algorithm. So remember when we spoke about genetic algorithms? This is where it all takes place. This is basically the model learning actually from the data that we are pushing through. And then what happens is you apply that genetic algorithm to the model. So genetic algorithms would be the part of the model where you're applying it to the model, and it can cause some randomness. What I mean by randomness or stochasticness is if the model is being built by data scientists in the team, then certain things would match. However, other bits might not match. And this is something that we would already know from our data scientists. And I'll explain a little bit about that later on as well to you. In terms of the learning algorithm, that's your predictive analytics. So predictive analytics is more around the use of data, statistical algorithms, and machine learning techniques to identify the likelihood of future outcomes based on historical data. Organizations use predictive analytics to sift through current and historical data to detect trends and forecast events and conditions that should occur at a specific time based on supplied parameters. So all of this happens as the main part of your model, and then it gives you future-like data. Another example I can give you here is, say if you're providing money on credit, then the probability of customers making future credit payments on time is a matter of concern to you. Here, you can build a model which can perform predictive analytics on the payment history of a customer to predict if the future payments will be made on time or not. Something we have to be very, very careful about is the elephant in the room. What I tend to say to all testers is try and be involved in every possible meeting in terms of your requirements or any kind of feature or planning sessions. Be present at all times. I know there can be a lot of meetings and a lot of information flowing through, but it's just a nugget of information that if we might miss, we might not, we might have an elephant in the room, basically. So I would suggest be part of requirements gathering, understand the problem and the data that you're trying to use, understand the shape of your data as well. Be part of the planning sessions where you brainstorm possible solutions. It's not just for developers to come up with solutions, but even testers can come up with useful solutions. Be part of the design team, offer any kind of accessibility knowledge that you might have if it's a front end that you're building for your model as well. Any kind of try and work with that design as well, see how viable it is. Obviously, once the design is implemented, try and test it as soon as possible. And one more important thing is be part of the Three Amigos session, because from the business perspective, what is the problem we are trying to solve? That's the question we are going to ask. From the development side of things, you can potentially ask them, how might we build a solution to solve the problem? And from the testing side of things, we could potentially ask what could possibly happen, or how would your implementation impact the product? So these are kind of important questions that you can always ask your within your teams. And remember to be part of everything and avoid any elephant in the room. Let's get started. So a model could be off the shelf or a model could be custom made. Depending on what it is, you need to basically have testing strategies or processes around that. Also, you should consider how often you want to train your model. So basically inputting data, running the model, and learning from its outputs. There can be a degree of randomness in a model, as I explained earlier. What I mean by this is, say for instance, for me and you, 5 plus 3 is 8. What the model could do here is take the 5 as it is, the plus as it is, and the 3 as it is, but result might be 8.00000065. Now, when I see a number like that, I would be a bit shocked, thinking, right, something's not right over here. However, in terms of data science, what I've done is included some sort of thresholds. Basically, thresholds help us gain more confidence as to what we actually accept and what is 100% no. So sometimes a number that might look a bit off might not 100% be an anomaly. It might just be a deviated result, which is still acceptable. So this is something that I will explain to you further on as well. The testing process. So it's really important to verify the data set to use for the model. It's really vital to check the input data and check the data you have in your output as well and results, because it helps us do better validation or verification checks over there. Also, check the shape of your data as well. Testing the outputs will explain if the values are of the right type and the data columns are matching or not. Have some bounds on around averages, set some target results thresholds. So as I explained earlier, in my team, we had a threshold of 3 to 5% deviation. Anything above that, we would definitely create a little bug or discuss with a data scientist what's happened. Have we selected the wrong parameter, or has something changed in the model that we were unaware of? So these are the things you decide within your team. Now, also, it's important to have some bounds around averages, make sure no data is dropped or no duplicates as well. So you can check that in the areas you're certain and uncertain about and see what's happening. Make sure the data pipeline works as expected. So as I just suggested, no data is being dropped or duplications. Test using different parameters and try to see difference in results. So you're basically exploring the model. And at the same time, what you're doing is you're doing a passive way of performance testing, because every kind of parameter might be different. And if you play around with these parameters, they would explain to you how long the model is taking to run. Next would be to explore the model as well, because the model can provide random results each time you run. So brace the uncertainty. Try and understand if it's still okay or a complete anomaly. Another thing that I would like to also explain is exploratory testing is important here as well, because sometimes as testers, we are quite involved in feature testing and we just want to deliver. But sometimes there is a hidden bug here or there. And this can only be found when your head is clear, when we're not testing a feature specifically, but we are just going with a blank mind and testing our product, learning from it. And we might find a very underlying bug sat there that we never realized before. So I would definitely say, make sure you explore as much as possible. Some more around testing. So the testing that I've done with a data science model is testing new features that come in and regression testing. So when a new feature comes in, there is nothing really to compare the model run to. Since it's a new implementation, you can potentially find some issues around it. I'm not saying 100% there are issues, but there is a potential. You can apply different configuration parameters for edge cases to see how the model provides its outputs. So from a new feature perspective, you should work on a test plan with a data scientist, see if you understand it fully, and make sure there's no elephant in the room when you have new features coming in as well. Consult your results with a data scientist for more conciseness. Check if the logic is tested on unit tests. You can definitely pair with a data scientist and ask them to take you over those tests. Run a model prior to the new feature and after, because that will show you what improvements have happened. And do some exploratory testing, because you never know what you might find. So this is part of a new feature. In terms of regression testing, so as we all know, regression testing is just to confirm that a recent program or code change has not adversely affected existing features and make sure any bugs that were found previously in a release, they are potentially resolved. So in a regression testing, what we do is we compare historic runs or delta runs, I call them, of a model to identify trends and comparisons. What I do is I have a new run for a new release, compare it to my historic run and see how different they are. If they're very similar, then I have the confidence that we are good to go. But if they're very different, then I have some sort of consultation with the data scientist to understand if we are good to proceed and tick off this release or something's not right. Remember, some models can have a degree of randomness, but that's okay. It's fine, but we need to understand in this randomness what is acceptable or not. No equation for the best answer exists. Rely on a good enough and fast enough result. Basically, provide accurate predictions and insights that can be used to enable critical and strategic business decisions. Even with the advancements in technology, 100% automation in this kind of area is not currently achievable, as automated testing requires extensive maintenance, which is supplied through human intervention. And the reason why I'm saying a lot of the model cannot be automated is because the machine does not understand the calculations I want to perform and verify. So this is something that I do on the side on an Excel sheet because it's quick checks that I want to do, and it's for a specific reason that I'm checking. However, if you have a front end, which I do, we have automated that end to end, and it has resulted in some positivity in the team to have those automation checks being run. It basically gives us more confidence around our product. Some useful questions for you to think around is, what is an acceptable test? Has a run completed and nothing broke within the various stages of a model? Have we found anomalies? Are they really anomalies, or are we thinking that these are anomalies? So obviously consult these within your team. Did we drop some data in a potential pipeline? If so, where? And has there been a leak before here or not? Or this is the first time? So we need to get to the root cause around here as well. How do we know that we've produced the right result? So set some target result thresholds. In my team, we have 3 to 5%, but if your business is more critical, such as credit card fraud, you might have a less percentage, say, for example, from 0.5 to 1% difference only that you can accept, or zero, completely no acceptance of deviation. So it's something that you set in your team. This is something that I set in my team. And then obviously the comparisons could be made between averages and sums as well to understand if you think the results are accurate or not. Some results should not be random, therefore expect the right results, an exact match. And what is an acceptable deviation? So this is for you in your team to strategize and see how you can, what is an acceptable deviation? So basically, with all of these kind of questions answered, you will gain confidence levels and precision from a delta run. Right, let's practice a little bit. So over here, you can see a data set for some locations and birds in those locations. So as you can see, A1 to D6 are some locations and the numbers of a number of birds in those locations. So if I were given this data, I would potentially ask the following questions. I would potentially ask things like, how many sites are there in total? Just randomly say a question, how many birds were counted at the last site versus the first site? What is the total number of birds counted across all sites? What is the average number of birds seen on a site? I can also ask futuristic questions. How many birds am I expecting in site A1 next week, or next month, or next year, or in the next 5 years? What is the average number of birds seen on a site? What is the total number of birds counted on sites with codes beginning with C, and so on and so forth. So what happens is this data will get injected into our model. The model will do its magic, and then we can potentially see some graphs or some useful data or some segmented data that we can potentially provide this to a client, and they can potentially use this to optimize their business decisions. Other things we can think around here is, have we got a good understanding of what the model has provided? Are the predictive analytics working as expected? Does the shape of my data look as expected? So what I mean by the shape is not circles, squares, or triangles. I mean a histogram or a graph, depending on what your dashboard might provide. But I use standard deviation, the mean, absolute difference, percentage difference, to help me validate my results. There are some case studies as well online that you can potentially use and play around with as well. I can't remember right now exactly, but I'm happy to provide this on an email to STPcon to forward it to all the members who are here today. Right, some complexities. With data science being complex as it is, a lot of complexities come around it, especially when you are creating strategies and trying to understand the model to the best level you can. So how can we mimic the client data? So this is an important question. It's basically, it's following to the next question. If we anonymize, also, how do we work with it? So anonymizing data at first may work well, but complexities will come when more complex data comes in and new features are built around it. Therefore, a good solution would be to somehow mimic a golden dataset. I started anonymizing the client dataset, which was a bit long-winded. Then we tried to create an automated way, but we didn't really use the automated way. So it used to, basically anonymizing between 15 to 20 files can be quite time consuming. And there's also a fear of some data biases or losing some data somewhere. After that, we decided we're going to create a golden dataset, which worked much better for us because all the important features were in that golden dataset. Also, if we anonymize, we need the file size to match the client files. So something that I noticed was when I was anonymizing client data, their descriptions were quite big. So I was just calling them description 1, description 2, description 3, and so on and so forth. So my file size completely changed to a smaller file size compared to the clients. And I realized one of the consultants came back saying that our big files are not getting injected to the model and the model's throwing an error message. And that made me think, if I did not shorten these descriptions, would I have been able to catch this bug before? So if you are doing this, make sure you keep the file size as they are initially. Try and change the long-winded words to something full of characters and make sure the file size is matched. In terms of policies, if you're using client data, we need to respect their policies and make sure that once we have finished using their data, we do not have them on our system. Now, a model is also complex. I'm not telling you that you should learn the model in 1 month. It just takes time. I'm still learning it as well because there are so many new things around it. I did not come from a data science background, or I never studied it, but with the help of the friendly data scientists in my team, it helped me understand what's happening. It takes time to understand a statistical model. Therefore, take time to pair with developers and data scientists or data engineers to understand everything such as how it functions, the data schema that you're using, what is accepted as data, what is not. Explore the model. It's a massive playground you can explore. As long as you're not playing on a production environment, you can definitely research more. Avoid any knowledge silos as well. If you understand something or something new that you've learned, try and put them on a wiki page so that if a new tester were to join soon, they can go and read that useful information that you learned, or a developer, or even a product owner. Anyone in your team could potentially benefit from that information. Also, dependencies. It's important to capture dependencies beforehand rather than finding them out later. So what I mean by this is, if you are having a new feature that impacts the model and that will impact your front end, then make sure it's mentioned in your user stories, because you do not want the data scientist to go and change the back end side of things, and you test the back end, and then the front end developer is not sure that they are meant to do something in the front end, which is actually dependent on the model change, then basically we are wasting time here. So try and find every possible dependencies. And I say something always is, capture dependencies before they catch you. So that's super important as well. Some tips for you to take away. Understand the data from a business point of view. Don't derail. Make sure we stick to the consumer requirements. Review and analyze as much as possible, that being your specifications, your tests, scenarios, any scripts, reports, any document that you find vital, any information you find vital, make sure you can document it. Your model mimics real life scenarios with tons of assumptions. And so assumptions limit scopes as you cannot pick all of them realistically, as the underlying maths or algorithm will end up becoming too complex and interfere with what needs to be delivered. Be ready for discrepancies and embrace them. They're not all anomalies always. By providing statistics and facts for employees that can access anytime, you are creating a smart and savvy team that can use these insights to drive more business. Once you have a process within the team, stick to it and look for ways of optimizing it. We are not just optimizing a model here, we are optimizing our teams too. Be present in vital meetings, and it's okay not to know everything. There are too many algorithms as it is. Pairing is super useful. Raise your concerns. Make sure new features are being released often and bugs are not repeatable. And what does this leave me with? This leaves me with a tester who learned data science validation and became a hybrid tester. Some useful tools that I found useful for me was SQL queries when we were using databases, but now we've got flat files, some statistics. You don't have to be a mathematics pro, but you can potentially get some help from a data scientist and not to worry about. Excel or Google Sheets, useful for doing your calculations, some dev tools if you're using a dashboard to test as well, and Miro board to do any kind of planning sessions or retros or any kind of discussions that you're having around a new feature. Before I end the session, I would like to summarize what I've mentioned today. Make sure you're doing some edge case style testing. Testing is not just to do a positive style testing. We should also test negative paths and edge cases. Explore the model as much as possible because you never know what you might find. Make sure the model is accurate and it meets its precision metrics. Make sure the model can perform at a scale with new features, because if your model can only perform at what you have now and cannot support future features, then your model is really not optimized in that way. So we need to make sure our model is maintainable and can support more and more weight on it, and make sure it's maintainable at all times. So thank you, everyone. I hope you liked my presentation. Feel free to connect with me on LinkedIn and Twitter. I think Mike will potentially forward those links to you. And yeah, I'm happy to take any questions.
Well, thank you so much, Laveena. That was a great presentation on data science models. And we do have some questions that we want to share with you and get your inputs on. And to those that are attending still, we still have the questions open. So just go in and type in your question here at the panel, control panel, and we'll get those questions to her. So keep sending them, and we'll start with the ones that we have so far. And the first question we had was, could you please repeat how mimic client data is done? That's from Kumar.
Yeah. So mimicking client data, you can have it in two forms. You can either have what do you call it, a golden data set. So mimicking their data. So basically trying to create similar data and making sure you have your main features for that client involved in that data set. Other ways of mimicking is anonymizing it. So you copy completely the same data, but you anonymize it. So say, for instance, if a client says the product one is, or product SKU 10567 is Coca-Cola 1 liter, then I would anonymize it as description 1, but you should try and do it like as many characters as possible to capture that Coca-Cola 1 liter. So you can add as many characters into that field so that it mimics the same characters that the client has. So it's super important that it's all matching, because as I explained, the file size should match as to what the client gave you. If you do change things here and there, it might impact maybe not yourself when you're testing, but maybe the client when they're uploading files and the thresholds of what a file size should be. So that's how I would explain that. I hope I've answered that question.
Okay, very good. Next question was, I really liked your diagram of the elephant and everyone getting everyone to talk about the product together. And what do you feel is the best way to integrate data science into the team if you have a team that's not using it, really
So,
focusing on it now?
so basically, how to introduce it.
Yeah. Yes.
Yeah, okay. How I would bring it in is if you see that there is some kind of potential of data science helping your clients, then I would definitely create a presentation first. I would explain the importance around data science and how models can optimize potential decisions for some clients and how they can even show potential things that clients didn't know about. So as I explained earlier in my benefits, opportunities that clients were not aware of. So you can potentially create a nice presentation for your team, introduce this. So basically you're putting some seeds into your team and you're going to let them bloom as flowers if they actually go ahead with it, and then you'll see it all go ahead. Once they're happy with your presentation, what you can do is potentially get some data scientists and have a little workshop and see what those opportunities could be for that client. I'm not saying this is going to be a one day's task or within 1 week you have data science in your team. This takes time, and I would suggest start from the very basics and slowly. So start from a presentation, go into a workshop, show some results back to your team, and see what you can do from there on. I hope that answered your question.
Okay. Yes. And I like this next question. It says, you spoke about how do we know what we produced is the right result? And you spoke about the percent of acceptable deviation.
Yeah.
Can you
So
explain more on that and why that's required?
yes. So how do I know my results are right? So this was something really ambiguous for me when I had joined the team. I saw so much data, and I went to the data scientist and I said, please, can you sit with me and explain what's right here and what's wrong? Or is everything accurate here? So basically, I sat down with them and it got so confusing at times that we just decided to come up with thresholds of what we are going to accept and what we're not going to accept. So that's where the deviation bit would stop. So if we have thresholds in place, any anomalies would be captured sooner rather than later. And what we do is we have delta run. So what I mean by delta run is a run that you created once you released. And then when a new release comes, whenever you're releasing next, you compare these runs. And what we tried to do is we automated this check as well. So we automated it all on Python, and we would input all the files from our Delta run, verse and also the parameters for our model that we used, the configuration file, plus the new configuration file that we just ran and the new files that we've just basically the results that we've gained, and just literally run this automation check and check what's different this time. Whatever was different, if it would fall under our threshold, we would happily go ahead and say this release was green in terms of testing. And if it wouldn't fall within the green, then we would do a bit more of digging. I would speak to the data scientist, and sometimes it would be a question of, right, you used a different parameter, and that would come out in my comparison tool. However, sometimes it would be a model bug. So this would stop us from releasing actually because we are providing the wrong results. So I would suggest always have a delta run or historic run present, compare it to your new run and see how different they are. I hope, Mike, I've answered that as well.
Yes, that was very good. Very good. All right. So we have two questions left so far. And again, folks, if you've got more questions, please keep sending them. The next one is data privacy is a growing concern among technology teams, especially around testing. And we've had policies such as GDPR and then the California Consumer Privacy Act, also known as CCPA. This
Yeah,
has changed not only how we test data, but also how we build in safety and production. So, do you have
yes.
suggestions for a team that wants to ensure data privacy needs are covered?
100%. Yeah. Yeah, I would definitely say have security testing in place, especially pen testers, because what I've noticed is in our application, a user that was not logged in could potentially even download PDFs, which is it's scary. For some reason, we couldn't test that, but a pen tester came in and tested that. So these are things that, as I said, leaks, right? Things that we are not checking. So pen testers and security tests, I would definitely say have that in your teams. In terms of GDPR as well, as I mentioned, respect your client policies. If you are anonymizing client dataset, use those files, finish with the anonymizing, and please remove them off your system. These days, people do tend to forget their laptops on an Uber or somewhere. We do not want client data just on your laptop and things like that. So as soon as you have used that client data, just please remove it off your system to make sure there's nothing there, nothing similar to it either. Just keep your anonymized files, because once your anonymized files are in the master branch, then you don't even need them locally. You can delete those too. So I would suggest that, and make sure you have some security testing in place, because you never know. Sometimes we are so concerned to do our feature testing, we forget about some non-functional testing. So I would definitely say have security testing in place, especially pen testing.
Very good. That is great. Well, I think that takes out. There was one question there around tools, but I think you covered that after the question popped up, and that was around tools that data
Yeah.
scientists or you or data scientists that you've worked with use. But I think you covered that with the several tools that was in your next to last slide there. But if you have any more that you want to suggest or anything that you would want to add to those, I
Yeah,
think we've
I
pretty much
mean,
covered.
I think with data science, it's quite Python related. So I've only met data scientists who are into Python. So I would suggest having some Udemy courses on data science or Python, just introductory, just to understand the lingo, the language that data scientists speak. That would be useful too. And don't worry, data science is not a one-day learn. It takes time. So don't really panic.
Yeah, I really like that suggestion on Udemy. That's a great suggestion. There's a lot of good stuff out there, to quick learn, and it's really affordable to take the courses. That's a great idea. Okay, well, thanks again, Laveena. It was a great webinar presentation. You did a great job. Had a lot of folks and a lot of interaction, and we hope that we get to have you here again for more of these down the road.
Thank you very much. And thank you very much, SDP community. Thank you all.
You're very welcome. Well, before we go today, folks, just a quick reminder, coming this summer, we have the Mile High Software Testing Conference in Denver, Colorado. It is just a week and a half away. So this two-day in-person event will take place 27th and the 28th, and it's going to cover all things software testing. So check out the workshops, the sessions, go to the link at milehighTesting.com. And I really think if you're near this and you can be there, you got to attend. I'm going to be there. Can't wait. It's going to be my first in-person conference since 2019. I'm excited. And we also want to mention that we're working on the program for STPCon, which is going to be in St. Louis in September. So we're working on that program right now. So stay tuned and keep checking on the site there as well. So thanks again, Laveena. We really enjoyed having you. And thanks to everyone who attended this webinar, and hope everyone has a great day and you stay safe. And we'll see you again.
Thank you. Bye-bye.
Thanks.